Okay, this is another paper 1-2 for February, March 2017, and question number 1. Look at this question number 1. Which expression has the same SI base unit as pressure? So the pressure is equal to force divided by area. Force is measured in kilogram, meter, second power minus 2, means this is the base unit, and the area meter square. 1 meter cancel, so it is kilogram. When this meter comes up, it becomes -1, second power minus 2. So this is the base unit, but we can write it kilogram over meter over second power 2. So this kilogram is the unit of the mass, meter for the length, and second for the time, but square. Now we have to match the answer, so answer is C. What is approximate value for the speed of sound in air? The value is 330. Or 300 to 330, any value. So the answer is B. This is the value of the speed of sound in air. And the next is the pendulum bob is held stationary by the horizontal force H. 3 forces acting on the bob are shown in the figure. The tension in the string of the pendulum is T. The weight of the pendulum bob is W. The string held at the angle of 30 degrees to the vertical. Which statement is correct? So by drawing, this is weight. This is horizontal force. And this line in this direction is tension, and this angle is 30 degrees. So it's a right angle triangle. Now the first possible expression is perpendicular over hypotenuse, mean H divided by T is equal to sine 30 degree. And the second possible is base divided by hypotenuse, mean W divided by T is equal to cos 30. And the third is perpendicular divided by base, mean H divided by W is equal to tan 30 degree. Now look at these. This first one is H divided by T cos 30. H divided by T is not cos 30, it is sine 30. This is wrong. Then T divided by H is sine 30. No. Sine 30 is H divided by T, not T divided by H. So this is also wrong. And W divided by T. So W divided by T is cos 30, not the sine 30. So the remaining is D. So D is the option. And we have W divided by T cos 30. So look this one. So D is the answer. Now move to the next. A student is investigating an electrical signal using the CRO, cathode ray oscilloscope. The frequency of the signal is 50 kilohertz. Which time base setting on the oscilloscope should be used? Look, time period is equal to 1 over frequency. So 1 divided by 50,000 because it's kilo. So the answer will be 1 divided by 50. It is coming 20 microsecond because the answer is coming 2 into 10 power minus 5 or 20 into 10 power minus 6 second, 20 microsecond. So this millisecond, and this is micro, this is micro. So we can take this one. So 2 boxes are sufficient for this wave. So 10 microsecond. And here, this is 0.4. 0.4, so no, this is out of the range. So the best answer is the C, this one. Because in 2 boxes, we can draw the whole wave. So the 10 microsecond is the best choice. This is wrong, this is wrong, this is wrong. The next student wishes to measure a distance about 10 centimeter to a precision of 0.01 centimeter. Which instrument is correct? Look, The distance from 1 centimeter to 10 centimeter is measured by vernier caliper more precisely. If the distance is more than 10 centimeter to 100, then we use meter rule. And if the distance is less than 1 centimeter, then micrometer. And if the distance is more than 100 centimeter, then we use tape measure or measuring tape. So here the distance is up to 10 and 2 decimal place, this precision required, definitely the vernier caliper. Next, an aircraft initially stationary on the runway takes off the speed of the 85 kilometer in a distance of no more than 1 kilometer. What is the minimum constant acceleration? So equation of motion, v square minus u square is 2as, initial speed 0, and this final speed 85. So first convert 85 into meter per second. So 85 multiplied by 1000 divided by 3600, then square is equal to 2, acceleration required, and the distance 1.2 kilometer, mean 1200 meter. So after calculation, you will get answer. So 850 divided by 36 square divided by 2 divided by 1200, and the answer after calculation is coming 0.23 is the answer. Next, a radio-controlled toy car travels along the straight line for a time of 15. The variation with the time t of the velocity of the car is shown. What is the average velocity of the car for the journey shown by the graph? So look, area of the velocity time graph is displacement. So here the displacement is 3 times 10 and 30 meter. And the next is, this is 6 side and this is also 30. So this is positive, this is negative. So the average velocity is equal to total displacement divided by total time. So total displacement is 0 because 30 plus minus 30 divided by the total time taken is 15. So 0 divided by 15, answer is coming 0. So the average velocity is 0 because the 30 displacement positive, 30 negative. So the resultant displacement 0. So the velocity resultant is average velocity 0 because the average velocity is total displacement divided by total time. And the next, okay, in the next question, the acceleration of the free fall on the Pluto is 0.66 meter per second square. The object weighs 6 Newton on the Earth. What would be this object weight on the Pluto? So weight W is equal to mg. M is constant. So we can write weight directly proportional to g. So W1 divided by W2 is equal to G1 divided by G2. So suppose W1 required and the W2 is 6 and the weight W1 for the Pluto is acceleration is 0.66 and the acceleration due to gravity on the Earth is 9.81. So the weight will be 0.66 times 6 divided by 9.81. So after calculation, the answer is coming this 0.40. Now move to the next. Water flows out of a pipe and hits the wall. When the jet of the water hits the wall, it has horizontal velocity v and the cross-sectional area A. The density of the water is rho, and the water does not rebound from the wall. What is the force exerted on the wall by the water? Look, first, The mass of the object is equal to density multiplied by volume. The mass is density area into height or area into the distance. And its velocity is given. So the initial momentum of the object will be the mass into velocity, mean rho a dv. And water does not rebound. It means the final momentum is zero. So what is the change of the momentum? This initial minus final. So rho a dv minus zero mean rho a dv is the change of momentum. Now, force is required. According to Newton's second law, F is equal to change of momentum divided by time. So the change of momentum is rho A d into V divided by T. But this d divided by T is also velocity, speed. So rho A V into V. So the final expression will be rho A V square. So answer is D. Now the next, a stationary firework explodes into three pieces. The masses and the velocities of the three pieces immediately after the explosion are shown. What are the velocities V1 and V2? So look, both angles are same, masses are same, so definitely the velocities will be same. So this component is V sine theta. This component also V sine theta, because both velocities are same. V1 and V2 will be same mass, same angle, so same velocity. So these two velocities vertically up, so they are balancing this velocity. So we can write V sine theta plus V sine theta is equal to 8, mean 2V sine 60 degree is equal to 8. Then V is equal to 8 divided by 2 divided by sine 60. So the after calculation, the answer is coming. Okay, this answer is coming 4.6 meter per second, but now we have to compare the masses. So its mass is double. These are the 50-50 half of the mass. So when you will double this velocity, then it becomes, because less mass, more velocity. So it becomes 9.2. So the answer is coming this B. Now there is another method. Okay, so we can apply here the law of conservation of the momentum. Initial momentum is zero total because they are stationary. And the final momentum, look, upward y-axis positive, downward y-axis negative. So we take the vertical component. So this is V sine theta, mv sine theta plus mv sine theta vertically up, but this down one is negative. So this mass is double. So it is supposed to m times 8. Now m is 50 gram. So it can be written as 2 into 8. It is 16. This one, 16 m is equal to 2 mv sine theta. I repeat, initial momentum is 0 because the objects are stationary. Then the vertical momentum of the first is mv sine theta. Second also mv sine theta, same masses. And then the downward, this is the negative downward y-axis. Its mass is double, negative, double mass, and the velocity this. So this comes here, so it becomes 16 m, then 2 mv. So m cancelled. So 16 divided by 2 is equal to v sine theta. It means the v sine theta is equal to 8, and v is equal to 8 divided by sine of 60 degree. So you will get straight 9.2 meter per second answer. Either use this or this method. It's up to you. And the next is a spherical object falls to the water at the constant speed. 3 forces act on the object. Which diagram showing these forces to scale is correct? At constant speed, mean the resultant is 0. Sum of upward is equal to sum of downward forces. So look, when these two arrows are added, their sum is not equal to this one. And look at the B, when these two arrows added in vertically up direction, their sum, yes, equal to the down, so B is the answer. Because sum of upward forces, these two arrows are added. So the size of this combination is equal to this bottom arrow, down arrow. So this is the correct option, because for the constant velocity, there must be equilibrium. Sum of upward forces must be equal to sum of downward forces. And the next question is, a uniform meter rule of the weight 2 Newton is pivoted at the 60 centimeter mark. A 4 Newton load is suspended from one end, causing the rule to rotate about the pivot. At the instant when the rule is horizontal, what is the resultant moment about the pivot? Look, it's a uniform. So its whole weight is acting at the middle. So weight 2 Newton here. And its distance from the pivot is 10 centimeter. So this is producing anti-clockwise torque. So 2 multiplied by 0.1, this is 0.2 Newton meter. And then this is 4 Newton, and its distance from the pivot, 100 minus 60, it's 40 centimeter, means 0.4. And its clockwise torque is equal to 4 multiplied by 0.4, mean 1.6. Now the difference of these two torque is 1.4, 1.6 and 0.2. The resultant torque which is produced is 1.4, the difference of two. Now the next. Okay, so the vertical forces that the ground exert on the stationary van are shown. One is 16,000, other is 9,000. It means the total weight of this vehicle acting downward is the sum of these two. So 16 and 9, 25,000 Newton is the weight of the lorry. The van is 2.5 meter long with the wheels at the distance of 0.600 meter from the front of the van and 0.400 from the rear of the van. What is the horizontal distance of the van, center of the gravity from the front of this? So mean this is the front, so this distance is required. So suppose we take this front wheel as a pivot and this distance is x, mean the distance of the weight from the pivot is x. Now, according to principle of the moment, clockwise moment must be equal to anti-clockwise moment. So this weight, 25,000 Newton, its distance x from the pivot, front wheel is the pivot, and the other force is this 9,000, and its distance from the pivot will be 1.5. So x is equal to 9,000 multiplied by 1.5 divided by 25,000. Let me calculate this. Okay, the answer of this x is coming 0.4 meter, but we have to measure from the front. So the gap between the wheel and the front is 0.6. So the total distance will be 0.54 plus 0.6. So it's becoming more than 1. So it is 1.14. So C is the answer, because the distance from the front is required. And this X distance is from the pivot, which is the front field. And the next. An object hangs by means of the two cord around the two rods as shown. The object is held in the equilibrium by the forces F1 and F2. The object weighed 10 Newton. There is a negligible friction between the rod and the car, and angle theta is 90 degree. Which row of the table gives an angle theta after 90 degree? Okay. So look, the weight of the object is W. It is 10 Newton. So this force is exerted in this direction. This is F2. And then the other is making 90 degree angle with this, mean this one. This angle is 90, and this is F1. Now we have to determine both forces F1 and F2. So definitely this force, look at the angle. These angles are not equal. This angle is small and this angle is large. So definitely this force is large. So F2 must be greater than F1, because this short string, short cord, has larger angles. So it will bear the large force, and this small angle, it will bear the longer one. Okay. So first observation is F2 must be greater than F1. So the options are greater than this and this. Okay. Suppose we assume this A. This is 6 and this is 4. Now we try the Pythagoras theorem. So 10 square is equal to 6 square plus 4 square. So this is not possible. Look, 36 plus 16, it's not 100. So move to this C. 36 plus 64 is 100. So hypotenuse square, perpendicular square plus base square. So the answer is C. So the first, we have to compare the forces. So this is larger than this force. So the short string will bear the large tension. Its angle is large and this angle is small. So it means F2 must be greater than F1. This angle is 90 given. And then we have to justify the Pythagoras theorem. Perpendicular square plus base square must be 10 square. So C is the answer. Next, which force is caused only by the pressure difference? So upthrust, so force experienced by the object due to pressure difference is called upthrust. And then the total energy input En in the process is partially transferred to the useful energy U, and the partially transferred to energy that is wasted. What is efficiency? Definitely output energy over input energy multiplied by 100. So A is the answer. Output energy U divided by input into 100. And the next 17. And gas is enclosed inside the cylinder, which is filled, which is fitted with a frictionless piston. Initially, the gas has a volume V1 and the equilibrium with external pressure P. The gas is then heated slowly so that it expands at a constant pressure, pushing the piston back until the volume of the gas has increased to V2. How much work is done? So we have done in the theory that the work done on the gases or by the gases is pressure multiplied by change of the volume. So this is the answer. This is not the half. This is added. Pressures, volumes are added. So here half no. So these are not the answer. pressure multiplied by change of volume. Now move to the next question. A projectile is thrown at the angle to the ground. Next question is question 18. At a certain time, the projectile has a horizontal velocity of 23 and the vertical velocity is -10. What is the speed of the projectile at this time? So look, we have to calculate the resultant velocity. This is the x component and this is the y component. And the resultant velocity is x component square plus y component square is the resultant velocity. So this is the formula. So the resultant velocity is x component mean 23 square plus minus 10.1 square under root, and after calculation 23 square plus 10.1 square, because the minus square becomes positive, and after calculation and taking the under root 23 in this, the answer is coming C. Next question is, a car of the mass 1400 kilogram is traveling on the straight horizontal road at a constant speed. The output power from the car engine is 30 kilogram. The car then travels up the slope at 2 degrees to the horizontal, maintaining the speed constant. What is the output power of the car engine when traveling up the slope? Okay, the car of the mass 1400 kilogram traveling the straight road, horizontal road at the constant speed of 25, the output power at this stage here. The output power is 30. The car then travels up the slope 2 degrees to the horizontal, maintaining the same constant speed. So due to the slope, extra power is required. So up the slope, the power formula is mgv sine theta, because the component of the weight acting down the slope is mg sine theta. That's a force, and force multiplied by speed is power. So the extra power on the slope is required, mgv sine theta. So m is 1400. This is 1400. G value is 9.81, speed 25, and sine of 2 degrees. So after calculation, okay, after the calculation, this answer is coming 11,983, so approximately 12 kilowatt. So the total power, now at this stage, the initial power 30 kilowatt. Now the extra power for the slope is also required. So 30 plus 12, it is 42 kilowatt. So the answer is C. Now move to the next question. Two wires X and Y are made of the different metals. The Young modulus of the wire X is twice that of the Y. The diameter of the wire X is half that of the Y. The wires are extended with the same strain and obeys the Hooke's law. What is the ratio? Tension in wire X divided by tension in wire Y. Okay. Two wires X and Y are made of the different material. The Young modulus of the wire X is twice that of the wire Y. Suppose the Young modulus of the Y is E, and the Young modulus of the wire X is 2E. The diameter of the wire X is half that diameter of the wire Y. So the diameter is half. It means its diameter is D and its diameter is 2D. The wires are extended with the same strain and obeying Hooke's law. What's the ratio of tension in wire X divided by tension in wire Y? Look, the Young modulus is equal to stress divided by strain. So they have same strain. It means E divided by L after both is same. So E by L is equal to F divided by AE. So they have same strain. It means the E by L after X is equal to E by L after Y. But E by L is equal to this. So we can write F over AE of X is equal to F over AE of Y. Now F divided by this area of the X is A, and the Young modulus of the X is double, then Y, then F divided by A. Look, the area of the Y is double. It means its area, this diameter is double. So the area will be 4 times. And multiply by the Young modulus of the Y is E. So this is for the X, this is for the Y. Now we can cancel. A cancelled, E cancelled. So we are left with F of X divided by 2 is equal to F of Y divided by 4. And tension of X divided by tension, it means Fx divided by Fy is equal to 2 by 4. And the 2 by 4 becomes 1 by 2. So B is the answer. So look at again, Young modulus is stress divided by strain. The strain E over L is F divided by AE. So it is same for both. It means F over AE of X, F over AE of Y. Then F of X, its area A, because this diameter D. And then its Young modulus is double 2E. Then F of Y divided by its diameter double, so area 4 times, and Young modulus E. After calculation, this Fx over 2 is equal to Fy over 4, then Fx over Fy 2 by 4, 1 by 2.